second degree trig equations that require factoring. So first off, we're going to learn how to factor these. This is that last question that I gave you. Remember that I told you was a bonus? So you could either have factoring where you have to take out a GCF or factoring where you do a trinomial. What I always do first is replace the signs with an x. So I'm going to say for now, x equals sin x. So we're going to get x squared minus 3x. How do I factor that if you got that in grade 10? If it's two terms, you can either do difference of squares. Is this a difference of squares? No, they're not perfect squares. Or GCF, that's it, when you have two. In this case, you can take an x out. And then once you're done factoring, so now I have two factors, I just replace the sine x back in with the x. So this is going to be sine x, and it's going to be sine x minus 3. And it's factored. We're never going to stop right here. We're never going to be asked to just factor, but we're going to go through factoring first and then solving right away. So we have 2 cos squared x plus 7 cos x minus 4. So what are we going to make be x this time? Cos. So we're going to get 2x squared plus 7x minus 4. So what times what equals negative 8? The 2 times the negative 4. What plus what equals positive 7? What's it going to be? Nope. Multiplies to give you 8. Adds to give you 7. No, multiplies to give you 8. You guys are multiplying to give 7. Yeah. So then you have to replace your middle term because it's decomp. So 2x squared plus 8x minus 1x minus 4. Could I write it 2x squared minus 1x plus 8x minus 4? Yeah. Then you group. When you group, there's technically a plus sign in there. Take a 2x out, and you're left with x plus 4. And then the last bracket, you can take a negative 1 out, and you're left with x plus 4. Because whatever you take out, you have to take out to match the other one. So out of here and here, I can take an x plus 4. And I'm left with 2x minus 1. If you still can't factor or do decomp, you need to come in at lunch and learn how. I don't have time to reteach it on how to do it, but you need to know how to do it. We're going to be doing it with basic sine, cos, and tan graphs. We're going to be doing with logs. So if you can't factor, you're going to be in trouble. Like you can't just say, well, I'm just not going to be able to. You won't be able to solve any of these questions. So when it's factored, I go back and I replace the cos x. That's what everyone forgets to do. They forget to replace the cos x, and they're just so happy they factored it. And then they just answer it as x equals negative 4 and x equals a half, and then they move on to the next question. No. Make sure you replace. So we get cos x plus 4 and 2 cos x minus 1. Like I said, we're going to keep going further on the next question, on every other question that we do. But we're just going over how to factor. So I want you guys to try C. Good times. So x squared minus x minus 2. Well, multiplies to give me negative 2 and adds to give me negative 1. X minus 2, x plus 1. Why could I go right to factors here but not to that one?
Because this one you have to do decomp.
Why? That was what I was at. Because there is a coefficient, but what is the coefficient? 1. What if it was negative 1?
Oh, then you have to multiply negative 2 by negative 1 to get the plus and minus.
And then you'd have to do?
And then you have to do decomp.
If it was equal to 0, though, which is what all the rest of them are going to be, you could just move everything to the other side, and then it would be a positive 1, and you wouldn't have to do decomp.
Really?
Option.
That's
Super awesome. Cos x minus 2 Cos x plus 1.
Oh, shoot. I wrote sine instead of cos.
Okay. Example 2. Yeah, probably more. Example 2. So this one here, what's the difference between this and the previous example? It's equal to something. If it's equal to something, you have to solve it. So,
Solve on the test.
yes. So,
It's the exact one. It's the exact one.
Except the one was over here.
Yeah. Yeah.
So what you always have to do is you have to move everything to one side, set it equal to 0, and then factor it. So what times what gets me -1 and what, or -2, sorry. And what plus what gets me -1? -2 and 1. -2 times 1 is -2. -2 plus 1 is -1. So I'm going to write it as 2x squared minus x minus 1 equals 0. I'm going to do decomp. 2x squared minus 2x plus 1x minus 1 equals 0. Take a 2x out, and you get x minus 1. What do I have to do for this back one? What do I have to take out of it? Nothing. So if I can't take out anything, what do I take out? A 1. X minus 1, oops, and then 2x plus 1. Now, if this was in grade 11, you would just go and solve it, right? Which we can do. Remember, if it was equal to 0, you had to keep going in grade 11. So you have x minus 1 equals 0, and you have 2x plus 1 equals 0. So this one's going to be x equals 1, and this one's going to be x equals what? Yeah, -½ because we'll subtract the 1 over, and then we'll divide by 2. So x equals -½ Now, scary part is when people stop there. You haven't done anything with trig yet, have you? So sine x goes in for x. So you get sine x equals 1, and sine x equals -½ Now this is exactly, oops, I forgot the x. This is exactly what we did before. We would just be given one of them, right? Now we just have to do 2. I always find my answers from 0 to 360 first, or 0 to 2 pi first, and then do the coterminals to that to fit into the domain. That is the easiest way to do all these questions. So where does sine x equal 1? We don't have to find the reference angle because this is on the unit circle. Where does sine x equal -½ We don't have to do the reference angle because it's on the unit circle. So where is y 1? When x equals
0. 1.
When does y equal what? 90.
90.
Some people say 270, but 270 is where it's -1. So you can't put that one. Okay. Now we need it to fit between -180 degrees and 180. If you want to do this right in radians, go ahead. But most people will choose to do degrees. Now the coterminal to that, if I add 360 to 90, I get what? 450? Does 450 fit in there? No. If I subtract 360 from 90, what do I get? -270? Does it fit in there? No. So that's the only answer I'm going to pull from there. Because any other coterminal angle outside of that's just going to be way more outside. Sine x equals -½ Where does y equal -½ In quadrants 3 and 4, right? So 210 and 330. Do 210 and 330 fit in there? No, so then this obviously gives me no solutions, which is what happened on the test yesterday. No, that doesn't obviously give you no solutions. That just means that these answers are not the answers, but their coterminals might be. So if I add 360 to them, I'm going to get even bigger, which is not helpful. But if I subtract 360 from 210, what do I get? Negative 150? Does that fit? Oops, 150. Yep, that fits. The 210 doesn't. What about 330 minus 360? Negative 30. Does that fit? Yeah. Now, if I did coterminals to those and kept going, would they be outside of that? Yeah. So my solutions are x equals 90, negative 30, negative 150. I usually start at the smallest negative and work up, but I didn't do that. I don't know why. Those are the three solutions. So the only difference is that you have to factor, and you're going to get two different ones that you're going to have to now solve more. So like I said, if you can't do degree 1 solving, you're not going to be able to do these at all because now you have two of them, right? Okay, then we're going to go to the next page if you have them printed off. What am I going to do for D? 2 sine x cos x minus cos x equals 0. I told you if you had a sine x, replace it with x. If you have a cos x, what could we replace it with? A y? So you're going to get 2xy minus y equals 0. What's the only thing we could do? And we're left with 2x minus 1. Now remember, if this was a plus y, it would be a plus 1. You can't drop that off. People always drop them off. Okay, that's common error. Equals 0. So now we have to split them up. So we get y equals 0 and 2x minus 1 equals 0. 2x equals positive 1 divided by 2. X equals a half. So now I'm going to write them up there. So y is cos. So cos x equals 0. And x is sine. So sine x equals a half. Oh, what did I forget to do on the previous one? The general solution I didn't worry too much about, but what did I forget to do? Yeah. This is pi over 2. This is negative pi over 6. This is negative 5 pi over 6. This is actually the solution. If I gave this, I would be wrong. Sorry, guys.
It's okay. Did you hear me running down the hall?
Yeah.
Didn't want to miss it.
If we wanted to do the general solution to these ones, pi over 2 is here, right? Negative pi over 6 is here. Negative 5 pi over 6 is here. Is there any way I can lump them together?
No. Yes. Yes. You have to go. How much is that? Hold on.
This is 90 plus 30, so this is 120. This is 90 plus 30, so this is 120. But then this is how much? 30 and 30 taken off of 180, so 120. So these actually nicely lump together. Is that always the case? No. These ones we just kind of left out. So our first positive one is x equals pi over 2. And then we're saying plus 120. What's 120?
Pi. No. Let's look. 2 pi over 3. And any pi.
So whenever I go to draw my general solution, I like drawing it out to see if there's any way I can lump some of the arms together, like if they're equidistant from each other. If they're not, you're going to have to plus 2 pi on every single, you'd have 3 of them. If these didn't work out that way, you'd have to go pi over 2 plus 3 pi, you know, and make it that way. But these ones also nicely lumped together. Okay. So we have cos x equals 0 and sine x equals a half. Because the domain is between 0 and 2 pi, I'm not going to do degrees first. I'm just going to pull them off the unit circle. You're just making your life longer, harder, more work. So where does x equal 0? On the y-axis, right? So x equals pi over 2 and 3 pi over 2. Remember, when we're missing this value here, we're missing the angle, so we're missing the inside of the unit circle. We're given the outside. Where does sine x equal a half in quadrants 1 and 2? Where does y equal a half? At the 30s. So pi over 6 and 5 pi over 6. So you guys, the key thing to doing these questions is that if there's a squared at all, unless it's a difference of squares, and if it was a difference of squares, you could do it that way too. Whenever there's a squared, just like whenever there's an x squared, you have to move everything to one side and set equal to 0. Remember that was embedded in your brain last year with quadratics. Whenever you have an x squared, you have to move everything to one side, set it equal to 0. So even this one up here, I know some of you will say, well, we could just square root it and get the plus or minus, which is what we did before. Yes. But what we could also do is we could just move it over. We could go sine squared theta minus 1 equals 0. Replace the sign with x. So x squared minus 1. And then just factor it. X plus 1, x minus 1. So x plus 1 equals 0. X minus 1 equals 0. X equals negative 1. X equals positive 1. So we'd have when sine x equals negative 1 and sine x equals positive 1. This way, if you forget to put a plus or minus sign in front of the square root sign, this gets them, right? Because you see the two factors. So whenever you see a squared and they ask you to solve it with sines or coses, the tans or whatever, move everything to one side, set it equal to 0 whenever there's a squared. Okay? And then where does y equal negative 1? At 3 pi over 2. And where does sine equal positive 1? At pi over 2. Are we done though? This is a full rotation backwards as well. It's from negative 360 to positive 360. So I have to subtract 2 pi from this, or subtract 360 from 270. Like this is 270, and I subtract 360, and I get negative 90. So I also have negative pi over 2. And then this one is 90, subtract 360, which is negative 270. So I also have negative 3 pi over 2. Okay? And on Thursday, the week we come back, I'm going to hugely go over general solutions because I always find that's something that people struggle with a little bit more. Okay?